Here we will focus on the last component of the formed elements, which are the platelets. Platelets are also referred to as thrombocytes. Platelets are typically found in a quantity of about 150,000 to 400,000 platelets per microliter of blood. They function to form platelet plugs, which are going to help slow blood loss from damaged blood vessels prior to blood clot formation. Platelets are actually fragments of cells. The platelets are formed from cells in the red bone marrow that are called megakaryocytes. The megakaryocytes shed pieces of themselves into the bloodstream, and these pieces are the platelets. The megakaryocytes are formed from the same hematopoietic stem cells that form the erythrocytes as well as the leukocytes. So they have the same developmental pathway that the other cells in the blood also have. So they share that feature. Platelets function to form temporary plugs in broken blood vessels. They also contain enzymes as well as chemicals that are going to promote clotting, which clotting will occur after the platelet plug has formed. So now that we are familiar with the platelets, we can examine the process of hemostasis, which is the protective mechanism that is set into motion when blood vessels break. Hemostasis has three events: the vascular spasm, the platelet plug formation, and then finally coagulation. Vascular spasm is the contraction of smooth muscle in the blood vessel walls. This slows blood flow to the affected area, and we see that the spasm is going to be stronger if more damage has occurred. The slowed blood flow will also assist with coagulation, and we'll see more about how this works in just a moment. Platelets that are encountering the break in the vessel become activated, and then also as a result of becoming activated, become very sticky. These sticky platelets will then release two substances. The first is ADP, which is going to cause more platelets to stick to the site, as well as a chemical called serotonin, which is going to enhance the vascular spasm that's occurring. And finally, during coagulation, we see that a mesh made from a protein called fibrin forms when coagulant clotting factors are activated. This mesh is going to help reinforce the platelet plug until healing can occur. So speaking of the clotting factors, we'll review a few important items from the clotting factors here. In total, there are 13 clotting factors that are found in the bloodstream. The first one, which is called fibrinogen, we are already familiar with, because fibrinogen is converted into the protein fibrin when it becomes activated. The other 12 factors we will not examine in detail, but we will look at some common factors among many of them. Most blood clotting factors are made by the liver, and they circulate freely in the plasma as plasma proteins. They only become clots when they are activated, and until they are activated, they will continue to circulate freely in the blood plasma. Several of them require vitamin K, which is circled in red, in order for them to be synthesized properly. And in the purple circle, I've highlighted two of the clotting factors that can lead to hemophilia if they are not produced correctly. Hemophilia is a disorder resulting from low production of two of these clotting factors. Individuals who have hemophilia will continue to bleed because clots are unable to form correctly. The coagulation, which is also known as blood clotting, occurs in three phases, very simply designated as phase 1, phase 2, and phase 3. So we will summarize the three phases here. Phase 1 involves two pathways to clot formation, the intrinsic pathway and the extrinsic pathway. The intrinsic pathway is named for the fact that clot formation is started by platelets, which are found intrinsic to the blood, because the term intrinsic just means within. And the intrinsic pathway occurs when platelets encounter the deeper connective tissues in the damaged blood vessel. So this contact with those connective tissues serves to activate the platelets, which causes them to stick to the rough surface of the break or the tear in that blood vessel, and it promotes platelet plug formation, and also activates the clotting factors as well. The extrinsic pathway is named for the fact that clot formation is started by damaged tissues that are located outside of the blood vessel. Damaged tissues will release a substance called tissue factor, which activates the extrinsic pathway when blood is exposed to that tissue factor. So at the end of phase 1, a substance called prothrombin activator is created, regardless of which pathway, that is the intrinsic or the extrinsic pathway, is involved. Typically, both pathways are involved. So during phase 2, prothrombin activator, which is formed at the end of phase 1, prothrombin activator is an enzyme, and it converts a plasma protein called prothrombin into thrombin. And so that is phase 2. And finally, we have phase 3. And during phase 3, we see that thrombin, which is formed at the end of phase 2, will activate fibrinogen, converting fibrinogen into fibrin. Fibrinogen is soluble and dissolved in the blood. However, fibrin is a fibrous protein thread, and it is not soluble in the blood. When fibrin becomes activated, it forms a gel-like mesh that helps to trap blood cells and reinforce the platelet plug that's already sealing the blood vessel in order to help create a sturdy seal in that particular blood vessel. Thrombin also activates blood clotting factor 13, which is called fibrin stabilizing factor. This helps to link the fibrin threads together and form a stronger fibrin mesh. So clot formation is a positive feedback mechanism, which means that if it is not controlled, the clot could become unnecessarily large and clog up blood vessels, that is, clog up blood vessels in places where clots and clogs don't need to occur. Two key items will prevent clots from becoming too large. The first is the rapid removal of clotting factors by fast-flowing blood. Fast-moving blood helps to prevent clots from forming because what it does is it dilutes the amount of clotting factors that are in a particular area. So when blood has a chance to slow down and pool, then it tends to concentrate the amount of clotting factors in the area, and it's going to be more likely that a clot is going to occur as a result of that. So this helps to explain why the vascular spasm, as well as applying pressure to wounds, helps to promote blood clotting, because both the vascular spasm and applying pressure to wounds are going to slow blood flow to the affected area. The second is inhibiting the activated clotting factors. So any thrombin that moves away from where that clot is formed is very quickly inactivated by a protein in the blood plasma called antithrombin 3. Heparin, which is a substance that's produced by the basophils, will enhance the activity of antithrombin 3, which helps to explain why heparin functions as an anticoagulant. So even with all of the protective mechanisms in place, we see that coagulation and clot formation can still occur at improper times and under very certain and specific circumstances. The first is that if blood vessels are rough, that is if they are clogged by atherosclerosis or by inflammation, the rough inner surface of blood vessels will attract platelets, and then the platelets will begin to cling together, which are going to initiate the intrinsic pathway for phase 1 of clotting. Another factor that promotes abnormal coagulation is pooling of blood, because it increases the local concentration of coagulants. And we would see that this increase in the concentration of these coagulants will promote coagulation. Blood can pool when we are sitting for extended periods of time, so for example on a long flight. And this is why it's recommended that you get up and move around frequently, because it reduces pooling, particularly in the lower limbs, and in doing so it's going to reduce the number of clots that form as a result of that pooled blood. Another condition that can promote abnormal coagulation is a condition called atrial fibrillation, or AFib. And AFib causes blood to pool in the atria because AFib is where the atria, the upper chambers of the heart, are beating out of sync with the ventricles, which are the lower chambers of the heart. And if the atria are not beating in sync with the ventricles, this would cause blood to pool in the atria, and it could promote clot formation as a result of that pool of blood sitting in those atria.